Hey everybody, you are tuning in to What's Up with Giancarlo. It's me back again with the topic 5, lesson 3, solve inequalities using addition or subtraction. I can solve inequalities using addition or subtraction. And the Florida standard for this is MA.7.AR.2.1. Write and solve one-step inequalities in one variable within a mathematical context and represent solutions algebraically or graphically. So let's take a look at this. When we are solving inequalities, in this lesson we will be going over one-step inequalities. So to solve for the variable, whatever we see in the problem, we will be doing the opposite to solve for it. So if you see addition in the problem, to solve for it, we will be using subtraction. If there is subtraction in the problem, we will use the opposite, which is addition. For multiplication, we would use division. For division, we would use multiplication. Every single person should know by now what the inequalities are. Okay, we've got greater than, we've got less than, we've got greater than or equal to, and we've got less than or equal to. This is an equal sign, equal to, and this is a not equal sign. They are not equal to each other. All right? Let's go ahead and move on. So, example 1. Solve inequalities that involve addition. On the airline that Raul is using, the weight limit for both suitcases combined is 50 pounds. How much can Raul's second bag weigh without going over the limit? So, we see one bag is 38 pounds. This bag is 38 pounds. We do not know how big this bag is. Okay? We do not know the weight of it. So what we are going to title it is P for pounds. P for pounds of, or weight of the second bag is P. I don't know why they made it P. Maybe it's for pounds. Who knows? So P plus 38 has to be either less than or equal to this 50 pounds. Less than or equal to 50 pounds. Because it can equal 50, that's why it's equal to, but it cannot go over. So it has to be less than or equal to 50. So, you guys can build your walls to really separate the left side from the right side. And we see addition in the problem, so we are going to solve by subtracting. We need to get this variable P all alone. So we would have to get rid of this positive 38. So to get rid of it, we subtract 38. Okay? And whatever we do to one side, we must do to the other side to keep it equal. Or to keep it fair. Okay? So 38 minus 38 is 0. So I'm left with P on the left side. And I don't change the sign. It remains less than or equal to. And then 50 minus 38 would end up being 12. So this little suitcase can either be 12, or it could be 11, or 10, or 9, or 8, or 7, 6, 5, 4, 3, 2, 1. Okay? So it can be any one of those, but it cannot be more than 12. It has to be either 12 or less than 12. So that is solving for the variable to find out how much the bag can weigh. Now, if we were going to put it on a number line, this is how we would work it out. Please pause the video right now so you can copy all of this down. This is very important stuff. Alright, now that you have written everything down, let's go over it. So our greater than, and our less than signs is going to equal an open dot. Okay? So let me show you what that means. So we have a number line right here, and we'll say 8, 9, 10, not 8, 9, 10, 7, 8, 9. So if we have x is greater than 8, that means we go to 8, and we will have an open dot on 8, because that means it cannot be 8. That is why it is open. It must be greater than 8. An open dot does not include the number that it is on. Okay? But if we had, I should have just left all that. If we have x is less than or equal to 4, we have our number line, not a very good number line, sorry. 4, 5, 3. So when there's a line greater than or equal to, less than or equal to, it will be a closed dot. What that closed dot means is that it can be 4 or it could be less than 4. But that number 4 is included. It is allowed to be that number 4. Alright? So, if variable is on the left, follow the arrow. When I say arrow, I mean follow the sign. So this is greater than, and it's pointing to the right. Like, you can make an imaginary arrow out of it. So, on our number line, wherever the point is, we would go to the right. We'd make our own little arrow. Okay? So it's greater than this number. It's every number greater than the number that it's on. So that means if the variable is on the left, just follow the way the sign is pointing. But if the variable is on the right, do the opposite. So if I have 4 is less than x, the variable is on the right side. So on my number line, I'd go to 4, put my circle around the 4. That's 4. And then the sign is pointing to the left, but my variable is on the right. So it's going to be the opposite of where the variable is pointing. I'm a little sick right now, so I've got the sniffles. So that is why you hear all that. And if this was less than or equal to, this would be a closed-in dot. Beep boop beep 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 boop 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 beep 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 boop. Okay. So that is, this and this are very important. You need to know that when it is equal to, when it's greater than or equal to, less than or equal to, it is closed. Greater than or less than is open. And this is very important as well. You cannot get mixed up on the number lines. Alright? So let's do some work on those. Actually, pause the video, write all of these down. Okay? Steps for plotting on a number line. Step 1, you need to find out whether it's an open or closed dot. That is very easy. You should be able to tell immediately. Step number 2, number to plot the dot. If it's just x is less than 6, that's very easy. You know it's on 6. But if it's x plus 12 is greater than 8, you have to solve for it to get x all alone, and then you will be able to find the number to plot on the dot line, to plot the dot. Step 3, which way is the arrow going? That is the tricky part, okay? You cannot mess that up. But you should have paused this by now. You should have written everything down. We're moving on. I've got 4 different examples for you to work on, okay? Pause the video, work them out. Alright, should have paused it, should have worked them all out. Cool. Now you can check your answers. We'll go over them together. So step 1, open or closed dot for this. It will be open. Okay? Step 2, what number are we plotting it at? 8. It's right there for you. And step 3, which way is the arrow going? Well, the variable is on the left side, and the sign is pointing to the right, so we will go to the right. Number 2, step 1, open or closed dot. This is less than or equal to, I see the line, therefore I know it's a closed dot. Number 2. What number is it going to be plotted on? 13. It's right there for you. And then number 3. Which way is the arrow going? Well, the variable is on the left, and that the sign is pointing to the left, so my arrow will go to the left. It's not very hard once you get the hang of it. Number 3, step 1. Open or close dot. I see the line under it, so it is a closed dot. What number will it be on? 12. And number 3, which way is the arrow going? So my variable is on the right for this one. So I will do the opposite of which way the sign is pointing. The sign is pointing to the left, so my answer will be going to the right. Okay, number 4, step 1. The sign has a line under it, therefore it is a closed dot. Step 2, the number is right there for you. We will be plotting on number 6, on the number 6. 3, which way is the arrow going? Well, my variable is on the left, and the sign is pointing left, so we will follow the sign, and it will be going to the left. Excuse me for that. Just blowing my nose. So, fun little joke. How do you make a tissue dance? You put a little boogie into it. All right. Let's move on. So now I've got other examples for you. Solve the inequality using either addition or subtraction and then put it on a number line. Go ahead, pause. Work it out yourself. All right, hopefully you paused by now. You guys can make your walls. All right, so we see addition in the problem, so we are going to have to subtract on both sides. And that will cancel each other out. We're left with x on the left side is greater than 12 minus 5 is 7. So my final inequality is x is greater than 7. So you can either make a number line or just do the 3 steps. So 1, 2, 3, but I will also make a number line. This is the only one I'm going to make a number line for all the examples that we have. Okay, we'll say 7, 8, 9, 6, 5. Okay, so we see there's no line, so it will be an open dot on the number 7, and the variable is on the left. The sign is pointing to the right, so my arrow will go to the right. So on a number line, using this information, we plot an open dot on number 7, and then make our arrow go to the right. I don't know why I make such a big fat arrow, but that's just what I do. You know, I do what I do when I do what I do. That's just me. All right? So let's move on to the next one. Pause it. Work on your own. All right. Back at it again. Make our walls. We see subtraction, so we will solve by adding. We will add 7 to both sides. These cancel out. I'm left with y is less than 15 plus 7 is 22. I don't like these extra lines. Kind of a neat freak. So I will end up with y is less than, that looks terrible. I'm going to change that. Sorry. Oh my God. So y is less than 22. Step 1, step 2, step 3. Open or close dot. There is no line, so it will be an open dot on number 22. And the variable is on the left, and the sign is pointing left, so my arrow will go to the left. Bada bing, bada boom, you're done. There are a lot of examples, so hopefully you get it. You understand everything by the time we're done. Go ahead, pause it, work on your own. All right, so let's make our lines, our walls. We see addition in the problem, so let's solve by subtracting. I've got plus 8. I'm going to subtract 8 from both sides. I've got A is greater than or equal to 20 minus 8 is 12. I'm just going to leave the long lines because who cares? It's eating at me, but whatever, I'll leave it. So I have A is greater than or equal to 12. Step 1, open or close dot. We see a line. We see a line under it, so we know it is a closed dot. That is greater than or equal to, so it is a closed dot. On the number 12, and the sign is the variable is on the left, the sign is pointing right, so our arrow will go to the right. Hopefully you got that right. Let's go. Another one. Pause it. Do your own work. Draw the walls. Real thing. We see subtraction in the problem, so let's add to solve for it. Plus 10. Those cancel out. I'm left with B is less than or equal to 42. B is less than or equal to 42. So step 1, step 2, step 3. We should all know how to do the number line by doing this. So, open or close dot, there's a line under the sign, therefore it is a closed dot. It is on number 42, that's the number that's shown. And then my variable is on the left, and the sign is pointing left, so my arrow will go to the left. All right, moving on. And I'm just skipping all these because I'm not a big fan of these examples. But here are the key concepts if you want to look at them. I don't like that they went to the side instead of going under. That is not how we do math, but whatever. Thanks for tuning in to another sweet video of What's Up with Giancarlo. And remember, everybody, if you're watching the video, that means you're a part of the class. See you next time.